You should always check your factoring results by multiplying the factored polynomial to verify it's equal to the original polynomial given. Many times you can detect a computational error, which is in the numbers, or errors in the signs of your numbers by checking the results this way. Let's factor some more polynomials. We want to find factors of the first term and factors of the last term, such that the sum of the products of those factors is the middle term. So x squared can only have factors of x times x, and y squared can only have factors of y times y. They must have the same exponent for the variable base for its factors. So that leaves us factors of 6. So 3 times 2 or 6 times 1. Either one of these could work. It'll depend on the signs. I'll just try 3 times 2 first because that was my first guess. So this is the same sign for these factors to have a positive product. And to have a positive sum, then they must both be positive. So a positive 3y and a positive 2y. If we multiply across times the x, we have a positive 3xy. And a positive 2xy. Does that add up to positive 5xy? Yes, it does. So these are the correct factors. We'll take the cross terms here, x plus 3y. And the other cross terms, x plus 2y. So if we were to multiply these together, x times x is x squared. X times 2y is 2xy. 3y times x is 3xy, and 3y times 2y is 6y squared. So we add the like terms together, that's 5xy's, and that shows us that this is the original polynomial that we were given. Proves that we have the correct factors here. Our next example, we want factors of x to the 4th and positive 21. Such that the sum of the products of these factors is positive 10x squared in the middle. So factors of x to the 4th must have base x, and x times x is just x squared. So what if we made these two? X squared times x squared, that will be x to the 4th. So those are factors of x to the 4th. Then we want factors of 21, which could be 21 times 1 or 7 times 3. Let's try 7 times 3. Because 21 is a large number and 10, our goal for adding, is not. So let's look at the signs. If the product is positive, they have the same sign for the factors, and that makes that sign positive. So if we multiply across a positive 7x squared and a positive 3x squared, it does add up to positive 10x squared. So we will take these factors, x squared plus 3, and x squared plus 7. Our next example, we have this polynomial. We want factors of the first term and factors of the last term, such that the sum of the products of those factors is the middle term. Again, we have x to the 4th, so since these must have the same exponent, they've got to be x squareds for the factors. And then factors of 6 could again be 6 times 1 or 3 times 2. It depends on the signs. So let's try 6 times 1. We've got the same sign, both positive. So that'll be positive 6x squared and positive 1x squared. That does not add up. So we're going to have to try the other factors and see if that works. A 3 and a 2, both positive, so positive 3x squared, positive 2x squared. That does add up to 5x squared altogether. So we have the factors that we want for this polynomial, an x squared plus 3 and an x squared plus 2. Another example here, our polynomial, we can tell by looking at this that it's not in descending order because the highest degree is the last term and That actually works out fine because our first and our last terms are interchangeable, but it's better if we just go ahead and write this in the proper descending order first so that we can factor the polynomial this way. We will have equivalent factors no matter which way we do it. As long as your middle term is in the middle for your adding goal, then everything will work out fine. So factors of r squared have to be r times r. And factors of 30 could be 30 times 1, 10 times 3, 15 times 2. And I want to get 31 for my adding goal, so I think I'm going to try 30 times 1. That might be the only way to get it, right? So let's look at the signs. Same sign, both negative. And multiply across. R times 30 is negative 30r. And a negative 1r does add up to what we want. So we will have factors of r minus 30 and r minus 1. And we can always check by multiplying those back together to get the original polynomial.